the idea of center of gravity. The idea of center of gravity, in a brief sentence, is this: if we imagine an object, just any object, any random irregular shape, it's okay. If we think of an object like that, it has weight, and the weight, of course, comes from every point in the object, right? Every little bits of materials in the object has some weight. So that part has some weight, that part has some weight, that part has some weight, and so on. Now, the idea of the center of gravity is that the overall effect of all these contributions, all this little weight from the little each part of the object, the overall effect is that we can think of them as if they are all acting at a single point. Oops. Okay, let's draw a straight line downwards. So we can think that that the whole weight of the object, we can think of it as if it is acting at a single point. So let me write this down. Center of gravity is the point. Okay, let's try and be a little bit more precise here. It's the point where the weight of the body, object, ball, book, whatever, appears to act. Now that is the rough and kind of a little bit abstract description. But what we need to do is to make this more definite into something that we can actually calculate with. And anyway, what does it mean by point where the weight appears to act? Okay, so as a first step towards making this more concrete, in physics, we always want to be able to measure things or test things. Okay, so in order for this to be meaningful, it must actually be quite literal, in the sense that you can actually find these points. Okay, let's say I have a piece of rod. Let's say this is a uniform rod. Okay, all the weights are spread evenly across this. It can be a ruler, a meter rule, for example. Okay, now what can I think about the center of gravity of this ruler? Okay, now let's imagine something very simple. Have you ever tried to balance a ruler on your finger? Not as in with the ruler vertically, okay, but as in with the ruler horizontal. You put your finger somewhere in the middle, and you try to find a point where your ruler, doesn't fall down on one side. So let's say that's my finger. Okay, or just a triangular support, whatever. Now I can sort of move this ruler left and right and try and make it balance. You can try it now on your finger. Just find your ruler. It's not very easy, but if you are patient, you would eventually find a point where the ruler just about balances. Okay, it doesn't tip over to the left or right. Now actually, you've just found the center of gravity, because this what you've just done fits this description. The point where the weight of the ruler appears to act, because just by supporting the ruler at a single point, okay, you have balanced the weight, as in the ruler doesn't tip and fall anymore. So that's exactly it. That's exactly what it means. The point where the weight of the body appears to act is a very direct meaning. All right, it's not supposed to be abstract. So if we can find this point, we have found the center of gravity. And how do we find this point? Well, in a uniform ruler, it's pretty obvious. It's right at the center. Okay, you can just try it. But what if it's a non-uniform ruler? What if I take a lump of plasticine, for example, a lump of something, and stick it there? Okay, a chewing gum. Hopefully not. You can try that if you have one right now. So let's take a piece of plasticine on one side of the ruler. Then clearly, if we don't move this point, move our finger or our support, the ruler will just tip and fall because of the extra weight here. Okay, extra weight here, in addition to the weight of the ruler itself. Okay, so because the weight of the ruler itself appears to act through that point, we were able to balance it just now. But now that I have this extra bit down here, it tips and falls. Why is that? Well, let's continue to develop this meaning further. The point where the body appears to act, well, clearly the point where this combination of ruler and sticky plasticine appears to act is not here anymore. All right, and if it tips this way, the point might have shifted. If I use the center of gravity, we sometimes use CG as a short form. So the center of gravity might have just shifted to here, for example. So if why not try shifting our finger a bit to the left towards that lump of thing, and we should be able to find a place here, a new position here where we can balance it. So that's our new center of gravity. Okay, so we can always find a point where we can balance this ruler. Okay, then the next thing that we want to do is to be able to actually calculate this position. So now let me look at more concrete example. Now back to my ruler. Let's say I have this ruler. Okay, put in some numbers. Let's say it's a meter rule. Okay, so at the center of the ruler, it has a weight of say 0.1 Newton. Let's say that's the weight of this ruler, 0.1 Newton. Okay. Now suppose that I get my lump of plasticine or chewing gum, if you really have to, and stick it right at the end down here. So that's my lump of thing. Now, and suppose that this lump of I prefer plasticine anyway, so has a weight here of 0.05 of a Newton. Okay, all right, and since this is a meter rule, it's 1 meter long, so we know that the distance between this end of the ruler and the center of gravity, which is at the center of the ruler, we know that this should be half a meter, 0.5 meter. Okay, there we are. Good. So now what I like to do is to find the center of gravity. So I want to find a point. I want to find a point where the weight appears to act. So I don't know where it is. So let's imagine that it's somewhere there. Okay, I just imagine a place. Maybe a bit, closer to the weight of the ruler, because the weight of the ruler is a bit heavier than the weight of the plasticine. Okay, so suppose that's the center of gravity. Now I want to find where it is. So find as in the position. So we want I want a way to describe the position. Now, let me call that x. Okay, so that's my distance from there to there. There. Okay, and let's say that's my new center of gravity, new CG. How would we find this? But there is a way to do it, and the way is this: is to use the principle of moments. Okay, this, in order to balance it, right? If we let's not think about the center of gravity for now. Let's just think about balancing the two forces on the two sides. We can actually work this out using the principle of moments, because the turning effect from one force must balance the turning effect of the other force. So actually, if we know about moments, we already know how to find x. So I'll start by writing down the clockwise the anti-clockwise moments. From this force would tend to turn the ruler in the anti-clockwise direction. So anti-clockwise moments would be the force times the distance. So this times this. 0.05 x. That's the anti-clockwise moment. Now it must be equal to the clockwise moment. That would be this force times this distance. So 0.1 Newton times, I'll just put it next to this number. This number, this distance will be 0.5 meter minus x. So I'll put it in the bracket. 0.5 meters minus x. That's my clockwise moments from this force. And for this to be balanced, the clockwise moment must be equal to the anti-clockwise moment. And once we have written this down, well, we can solve for x. So here we go. 0.05 x. No, actually, what I'll do is this. Now there are decimals here, which makes it a little bit more complicated than just small numbers, just small whole numbers. So what I'll do is I'll multiply both sides by let's see. No, actually I just divide this out right from the start. I'm going to divide both sides by 0.05. 0.05 is half of 0.1, right? So if I divide both sides by 0.05, that cancels and that becomes a 2. Alright, that should simplify things. Now, so x is equal to, I expand this now by removing the bracket. 2 times 0.5 is 1 minus 2 times x is 2x. Okay, that looks much simpler. Now I'll move 2x over to the other side, so I'll get 3x is equal to 1, and finally this gives x is equal to 1/3, and the answer is in meters. Okay, so if you want to read this on a meter rule, I'll give it in decimal. 0.3333 of a meter. So that's the distance of this new center of gravity from one end of the ruler. So that's how we have found a point. So what we have done is that we have taken this idea, this abstract idea about a point where the weight appears to act, and turn it into something we can actually calculate. And clearly the method, the important method that we need to use is the principle of moment. I'll write this down, principle of moments.